Hey everyone, today we'll be looking at the three scenarios of projectile motion. And if you understand these scenarios inside out, you'll be able to answer literally any A-level physics question pertaining to projectile motion. So the question won't ever say that this is scenario one, this is just what I came up with. So in scenario one, what I call scenario one is when the projectile is launched, it lands at the same level it was launched from. And when it lands at the same level it was launched from, the total vertical displacement is zero. And since there are double motion involved, as in going up and coming down, the acceleration would be minus 9.81. This is what you need to remember at all times about scenario one. Now we move on to scenario two, where the projectile is launched horizontally. This part is very important. Horizontally from a height. And when something is launched horizontally, it does not have any initial vertical velocity. So one more thing to add is initial vertical velocity is zero. And since the motion is only in one direction, in the vertical direction, there are no two directions involved. So the acceleration is just 9.81. And the vertical displacement is equal to the height it was launched from. That's scenario two for you. I repeat, in scenario two, the projectile is launched from a height but horizontally. Now, scenario three. What I call scenario three is a combination of one and two, where the projectile is launched from a height but at an angle. So if it's launched at an angle, it will first go up, go above its point of launch and land below the point it was launched from, right? So if it lands below the point it was launched from, always remember when it comes to displacement, the point it's launched from can be considered to be the origin. All displacements above the origin is considered positive, and displacement below the origin is considered negative. So since it lands below the point of launch, the total vertical displacement is actually minus h. This is what a lot of times students mess up. They mix up scenario 2 with scenario 3, where they take the displacement as positive, but it's going to be negative because it lands below the point it was launched from. And in scenario 3, since it's going up and coming down throughout the motion, the only force acting on it is the weight, and this is the resultant force. So throughout the motion, since the resultant force is downward, the acceleration is also downward, right? So if the acceleration is downward, downward is generally considered negative. So the acceleration would be minus 9.81. So now you have a clear understanding of the three scenarios. And all you have to do is just apply them. And that's exactly what we're going to see today. We'll be applying the three scenarios in three different questions, three different recent questions of A-level physics. So let's get started. So this question is from May 2023, question 14. And why am I calling this scenario 1? Right? So let's see. A sportsman hits a ball with a bat. The bat leaves the ball leaves the bat at a speed of 37 meters per second at an angle of 53 degree to the horizontal as shown. So one more thing I have to add is you have to have a very clear understanding of vectors when it comes to projectile motion. And I would highly recommend you always mark the values as in the components in your diagram. This helps you a lot. So 37 has two components. So the horizontal component has an angle with it. So always remember with angle is cos theta. So this would be 37 cos 53, but the vertical component does not have any angle with it. So without angle is sine theta. So this would be 37 sine 53. So these are the two components of this 37 meter per second. Now, calculate the horizontal distance traveled by the ball before returning to the height it was hit from. So this actually gives it away. Before returning to the height it was hit from. So the moment you see that it lands at the same level it was launched from, this makes it scenario 1. The other thing that I would highly recommend is always keep the two scenarios separate, as in two aspects of the calculation separate. Never ever mix up horizontal calculations with vertical calculations. So the very first thing you have to do is calculate the time it takes to reach this level. So for the vertical aspect of the motion, let me write down vertically. Let's recall the equation. S equals ut plus half at squared. So the total vertical displacement is 0 and u is 37 sine 53 t minus because there is double motion going up and coming down. So throughout the motion, the value of acceleration would be minus 9.81. Minus 9.81 divided by 2 gives you minus 4.905 t squared. So the equation gets reduced to, if you make t common, one t is equal to 0, you have to look for the other t. So 37 sine 53 minus 4.905 t, because if I take t common, 1t equals to 0. So all you have to do is, therefore t equals, so the value of t that you get is 6.02 seconds. So all of this was from the vertical aspect of the projectile motion. Now we move on horizontally. And I have a very crazy technique and tip for all of you. And that would be, when you are dealing with the horizontal aspect of projectile motion, there is literally just one equation that you need to recall, and that speed equals distance by time. Why? Because in the horizontal aspect of the projectile motion, the horizontal velocity always remains constant. And for constant velocity, you can always use speed equals distance by time. So if speed equals distance by time, the question asks me to calculate the distance. So distance should be speed times time. So distance should be speed times time. Now, always remember, this time is mutual because you are just considering this separately, horizontal and vertical, but this happens at the same time. So the time it takes for the vertical motion to complete is the same time as the horizontal motion. So always remember, the time is always mutual for vertical and horizontal aspects of projectile motion. Now, talking about the speed, what speed do you take? Since you have already mentioned that you are now dealing with the horizontal aspect, you have to consider the horizontal component of the velocity, which is 37 cos 53. So 37 cos 53 times, like I just said, the time is always mutual, that is 6.02, which gives you 134 meter. And I did check the mark scheme. This is the exact answer. So if you found this video helpful so far, I will highly recommend you watch the full syllabus revision videos if you are an October or January candidate. So these are in the members only section. For a small fee, you can watch all my members only videos. I think you'll find them immensely useful. Now, let's move on to scenario 2. So in scenario 2, this question is from Jan 23, question 11. Let's recall what we had initially seen about scenario 2. What happens in scenario 2 is the projectile is launched from a height but horizontally. And always remember, the horizontal velocity in projectile motion always remains constant. So the initial velocity, horizontal velocity is 3.8. Guess what? The very final horizontal velocity would also be 3.8. But since it was launched horizontally, it did not have initially any vertical motion. So the initial vertical velocity is zero. That's one of the key features of scenario 2. Now, let's see. The stone is projected horizontally from a cliff. The initial horizontal velocity is 3.8 meter per second. The initial height of the stone is 12 meter. Calculate the horizontal distance from the bottom of the cliff to where the stone hits the ground. So they're asking for this horizontal distance. But for this horizontal distance, you need the time. Guess what? You generally, this is not a convention, this is not some rule or mandated rule, but what you generally do is find out the time from the vertical aspect of the motion. So let's recall vertically what you have. So vertically, I know the initial vertical velocity is zero. This is the height it drops vertically. So I can use the equation S equals ut plus half at squared again. This time the value of S is 12 equals, guess what? Since it's launched horizontally, there is initially no vertical motion. So initially u is 0. Guess what? So ut is also 0. The equation gets reduced to S equals half at squared or half gt squared. So half, the value of g is 9.81, and there you have your t squared. So all you have to do is just make t the subject of the equation. So t equals 1.56 seconds. So I want to add something at this point, and that would be, this is not my final answer. So never ever round off your interim calculations to 2SF. You can only round off your final answer to two significant figures. So since this was an interim calculation, always keep this at 3SF. So we are done with vertical aspect of the motion. Now we move on to the horizontal aspect of the motion. And do you remember, everybody? I told you all something. This is a very crazy trick that you can apply to literally any projectile motion scenarios. That is, when you're dealing with the horizontal aspect of the motion, you literally have just one equation. You don't even have to think what equation to recall. You just have to recall one, and that is speed equals distance by time. Why? Because in the horizontal aspect of projectile motion, the horizontal velocity always remains constant, and for constant velocity, the equation is always speed equals distance by time. So if speed equals distance by time, the distance should be speed times time. And this is the horizontal distance that the question is asking me to find out. And since I'm dealing with the horizontal aspect of the motion, the speed has to be the horizontal component of this velocity. So this is 3.8. And always remember, the time is always mutual. The time it takes for the projectile to complete its vertical motion is the same as the time it takes for it to complete its horizontal motion. So it's 1.56. This would give you a distance of 5.9 meter. And since this is my final answer, it's okay for me to round it off to 2SF. Before we move on to scenario 3, I would like to introduce you to a very interesting content that I made, and that would be the frequently asked questions and answers of Unit 1. Unit 1 is very repetitive, and similar questions come up all the time. So I've compiled all of the similar questions along with their answers into a PDF, and you can get the download link in the description. I have also included the download links, not the download links, the watch links of the full syllabus revision videos of Unit 1, 2, and 3 in the description. I think you'll find that very useful. Now, the moment of truth. This is one of the trickiest projectile motion questions that appeared in Jan 25, question 19. I call this scenario 3 because this time the projectile is launched from a height but at an angle. And whenever you see a velocity at an angle, my first suggestion would be always write down the components. This helps you visualize the whole scenario. So this is 500 and the horizontal component would be 500 cos 22 and the vertical component should be 500 sine 22. Now, there will be an exception here. I told you all that we generally find out the time from the vertical aspect of the motion. Like I said, there is not a rule, right? There is just a convention. That's what we generally do. But now you'll see there is an exception in this question where the time has to be found out by considering the horizontal aspect of projectile motion. So now I know the horizontal velocity component and the horizontal distance it travels before it reaches the ship. The question says, part 1, show that the projectile was vertically above the ship about 30 seconds. So this is a show that question. And I'll tell you what is the mandated rule for answering show that questions. About 30 seconds after the launch. You should ignore the effects of air resistance. Fine. So like I said, you have to consider the horizontal aspect of the projectile motion. So horizontally, do you remember there is only one equation and that's speed equals distance by time. So if speed equals distance by time, therefore the question is asking you to calculate the time. So time should be distance by speed. So time should be equal to, of course, we are considering the horizontal aspect of motion, horizontally. So horizontally, the distance that it travels is 15 kilometer because it has to be vertically above the ship. So if it has to be vertically above the ship, it has to travel the same distance horizontally as the ship. That is 15 kilometers. So distance is 15,000 meters. Of course, you have to convert the kilometer to meter divided by horizontal speed is 500 cos 22. So the value of time that you get is 32.4 seconds. And like I said, the rule for answering any show that question is give your answer to at least one significant figure higher than the show that value. So if you can see, the show that value is rounded off to 1 SF, so it has to be given to at least 2 SF. And to stay on the safe side, I gave this in 3 SF. Now moving on to the part 2. Determine the height above the sea level of the projectile as it passed over the ship. You should ignore the effects of air resistance. So they're asking you to calculate this height. Okay, or you can just call this SV. V as in the vertical displacement. Now, so vertically, Let's recall the equation. S equals ut plus half a t squared. So this S is what you have to find out. So S should be equal to, U should be the vertical component of the initial velocity, that is 500 sine 22. So 500 sine 22, and like I said, time is always mutual, that is 32.4 minus, since it's double motion, is going up and coming down, so throughout the motion acceleration has to be minus 9.81, and minus 9.81 divided by 2 gives you minus 4.905, 32.4 whole squared. So the S that you get is, so SV should be, if I take 32, if I leave out the 0.4, the value should be 971 meter. Now, the question asks me height above the sea level of the projectile. So, along with this, what you have to add is the 2 kilometer, the height, right? So, if you add them up, what you get is, oh, one more thing I forgot to add, that was, this was the height that you have to find out, and you don't know if this was below the point of origin, and right? So, the total vertical displacement from the origin is this, because you are always considering the vertical displacement from the origin, that is 971. But if I have to find out the height, which you don't know if it's above or below, what you have to add is this 2 kilometer, which is 2000 meter. So the H equals to 971 plus 2000, which is approximately equal to 3000 meter, or 3 times 10 to the power 3 meter. So if this is your origin, this is the vertical displacement, because you always consider the vertical displacement from the origin. And on top of this vertical displacement, you have to add up this 2 kilometer to get the total height above the ship. So like I said, this was the trickiest projectile motion question ever. If you found this video useful, don't forget to subscribe and look into the other content in the description. Thanks for watching.